Within the vast expanse of Yellowstone National Park lies a hidden danger that has recently sparked widespread concern. While the park's breathtaking landscapes and diverse wildlife captivate visitors, seismic events beneath the surface have raised alarms. Thousands of earthquakes have been recorded, prompting authorities to monitor the situation closely. As fears escalate, tens of thousands of residents in surrounding areas are fleeing their homes, fearing the potential consequences of a catastrophic eruption from the Yellowstone Supervolcano. Yellowstone National Park, with its breathtaking scenery, has long captivated the hearts of visitors. Yet beneath its tranquil surface lies a silent threat, a supervolcano. Deep beneath the park's picturesque landscapes, two massive magma chambers lurk, silently filling with lava each passing day. However, alarming events have recently unfolded, prompting concerns among park officials. Despite the park officials keeping quiet on the matter, Anonymous, the notorious hacker group, has uncovered unsettling revelations. Yellowstone Park has closed its doors, and ominous activity brews beneath the Earth's surface, unbeknownst to most. On average, the park experiences 1,500 to 2,500 earthquakes per year, with clusters occurring within a few weeks. But recently, seismic activity has intensified, surpassing 340 earthquakes per week, signaling a concerning escalation. These tremors, though imperceptible to human senses, signify significant geological unrest. While Yellowstone is commonly perceived as dormant, this ongoing activity underscores its potential for catastrophe. Despite the absence of detectable seismic shifts, the frequency and intensity of these tremors hint at a looming threat. The specter of a major eruption looms large. Yellowstone's vast caldera and escalating seismic activity portend a potential catastrophe. Though the absence of noticeable earthquakes may deceive observers, the imperceptible tremors foretell a perilous reality. Advanced technology enables the detection of these minute seismic movements, alerting us to the underlying unrest. Supervolcanoes. The term supervolcano denotes a volcanic entity that has experienced a monumental eruption, ranking an impressive magnitude 8 on the Volcano Explosivity Index. This classification signifies an eruption spilling over 1,000 cubic kilometers of material. Recently, the phrase super eruption has emerged as a popular term to describe such eruptions succinctly and catchily. These explosive occurrences are of such colossal scale that they give rise to a circular-shaped collapse feature known as a caldera, marking the spot where the immense volume of magma was once housed. Supervolcanoes like Yellowstone stand out in the geological landscape due to their immense proportions and the potential for cataclysmic volcanic outbursts. These eruptions dwarf typical volcanic events, often ejecting thousands of times more material than their smaller counterparts. Yellowstone's heart lies in the Yellowstone caldera, the volcanic feature synonymous with the supervolcano. A caldera, resembling a large bow-shaped depression, forms when a massive volcanic eruption evacuates the underlying magma chamber, causing the ground above to collapse. The signs of an impending eruption are not to be ignored. The ground beneath Yellowstone experiences frequent seismic activity, hinting at the looming threat. Additionally, the surface may undergo deformation, rising or falling in response to the movement of magma below. Such changes are meticulously monitored using advanced techniques like GPS to detect abnormalities. The movement and accumulation of magma beneath the Earth's crust have far-reaching effects, especially on hydrothermal systems. These systems, encompassing hot springs, geysers, and steam vents, are sensitive to changes in temperature. A rise in temperature within these hydrothermal features could indicate the intrusion of magma closer to the surface. Moreover, the chemical composition of hydrothermal fluids undergoes alterations when in contact with magma, offering valuable insights into the geological processes at play. Park officials remain vigilant, continuously monitoring these hydrothermal features for any signs of abnormality and ensuring preparedness for any potential volcanic activity. Despite these efforts, the unpredictability of nature remains a constant challenge. Magma movement can lead to the deformation of the Earth's crust, impacting hydrothermal features and their behavior. While rising magma generates heat that affects surrounding hydrothermal systems, fluctuations in temperature, possibly influenced by climate change, pose additional challenges. Geysers. Geysers, those fascinating hot springs that erupt periodically, are a marvel of nature. Their eruptions result from superheated water from beneath the ground, becoming trapped in channels leading to the surface. However, geysers, renowned for their periodic eruptions, can be quite sensitive to disturbances beneath the Earth's surface. When these disturbances are caused by movements of magma or changes in pressure, the behavior of geysers is affected. Indeed, variations in the intervals, durations, and intensities of geyser eruptions have been observed, providing ample evidence of the possibility of a supervolcano eruption rather than a typical one. Notably, there has been an observable increase in gas emissions within the Yellowstone region, particularly those containing sulfur compounds such as sulfur dioxide. Hydrogen sulfide, constituting approximately 0.15% of these gas emissions, contributes to a distinctive odor reminiscent of rotten eggs that can be detected in specific areas. This is cause for concern as it is associated with magmatic activity. Magma, containing dissolved gases, releases these gases as pressure decreases. Therefore, monitoring gas emissions around hydrothermal areas, as in Yellowstone, is paramount, as it can provide evidence of heightened volcanic processes even without accompanying tremors. However, earthquakes play a significant role in this narrative. The Yellowstone caldera formed due to three massive eruptions over the past 2.1 million years: the Huckleberry Ridge eruption, the Mesa Falls eruption, and the Lava Creek eruption, each incredibly destructive. The Huckleberry Ridge eruption. The first and largest eruption, known as the Huckleberry Ridge eruption, which occurred approximately 2.1 million years ago, marks a pivotal moment in the geological history of North America. This remarkable event gave rise to a colossal volcanic feature, stretching an impressive 47 miles across the landscape, traversing Yellowstone National Park in Wyoming, and reaching into Idaho's Island Park region. The resulting caldera, a massive volcanic crater, emerged as a testament to the eruption's staggering force. The eruption of the Huckleberry Ridge Tuff, characterized by the expulsion of volcanic material, ranks among the most significant volcanic events documented on Earth. Its astonishing estimated volume of 590 cubic miles of material far exceeds the scale of most volcanic eruptions. To put this into perspective, the volume of volcanic rock produced by this eruption dwarfs the famed Mount St. Helens eruption of 1980 by a staggering 2,400 times. The aftermath of this Yellowstone supereruption left a profound impact on the surrounding environment and beyond. The immense volume of ash generated during the eruption formed what is now known as the Huckleberry Ridge Tuff, a vast expanse of consolidated volcanic ash stretching from Southern California to the Mississippi River. The eruption likely unfolded in three distinct phases over the span of decades, each marked by violent volcanic explosions that expelled materials such as ash and pyroclastic flows into the atmosphere at high speeds. Yet, just when it seemed the situation could not deteriorate further, it did. The Mesa Falls eruption. The Mesa Falls eruption occurred approximately 1.3 million years ago, making it the second most recent caldera-forming event from the Yellowstone hotspot. Preceded by the Huckleberry Ridge Tuff, and followed by the Lava Creek Tuff, both products of the same hotspot, this event played a significant role in the region's geological evolution. The eruption led to the creation of the Henry's Fork caldera, situated west of Yellowstone National Park in Idaho. This formation is a prominent feature resulting from the volcanic activity, expelling an estimated 280 cubic miles of material, though about half the volume of the Huckleberry Ridge eruption. Nevertheless, this eruption ranks among the largest known events in the Yellowstone hotspot's history. Beyond its size, the Mesa Falls eruption holds great geological importance. It contributed to the development of the Yellowstone Plateau volcanic field, shaping the area's distinctive features. The resulting rock formation, the Mesa Falls Tuff, formed through the compaction and welding of volcanic ash and fragmented rock layers. This process created a dense, enduring rock structure that has endured over time. The materials ejected during the eruption added to the volcanic deposits within the caldera, aiding in its expansion. The resulting Henry's Fork caldera spans approximately 15.5 miles in width, further enriching the array of massive volcanic features in the region. The Lava Creek eruption. The Lava Creek eruption stands out as a pivotal event in the history of the Yellowstone hotspot. This phenomenon has captivated scientists and enthusiasts alike for centuries. Unfolding approximately 640,000 years ago, it remains etched in geological memory as one of the most substantial eruptions associated with the hotspot's activity. The magnitude of the Lava Creek eruption is staggering, with an estimated volume of around 500 cubic miles of material ejected into the atmosphere, reshaping the landscape in unimaginable ways. While slightly less monumental than its predecessors, this cataclysmic event added another layer to the destruction they left behind. The fallout from the eruption blanketed much of North America, depositing what is now recognized as one of the most widespread airfall pyroclastic layers in history. This dense, tough formation is a stark reminder of nature's awesome power, formerly known as the Pearlette Type O ash bed in the United States and Wascana Creek ash in Canada. Today, remnants of the Lava Creek eruption are well preserved and prominently displayed at various locations within Yellowstone National Park. Visitors can marvel at the imposing tough cliff along the Gibbon River, witness the majestic Virginia Cascade, or simply drive along U.S. Highway 20, where the scars of ancient volcanic activity are bare for all to see. But what if history were to repeat itself? What if Yellowstone were to experience another supervolcano eruption in the present day? The answer is simple yet chilling: absolute chaos. Supervolcano eruptions, fueled by the accumulation of vast amounts of magma beneath the Earth's crust, unleash unimaginable devastation upon the surrounding landscape. The initial signs of an impending supervolcano eruption would be unmistakable. A significant increase in seismic activity, marked by a series of earthquakes of varying magnitude, would serve as harbingers of the impending catastrophe. These tremors, indicative of the restless movement of magma beneath the Earth's surface, would herald the onset of a calamity of unparalleled proportions. Recent observations of Yellowstone's volcanic activity have provided cause for concern. Since March 2018, there has been a noticeable shift in the frequency of eruptions from the famed Steamboat Geyser, once a rare occurrence, but now a regular phenomenon, sometimes erupting as frequently as once a week. Such unprecedented activity, unprecedented in documented history, underscores the urgency of understanding and preparing for the potential consequences of a supervolcano eruption. In 2014, a significant earthquake measuring 4.8 on the Richter scale rattled the Norris Geyser Basin, which rarely experienced seismic activity. This event was a stark reminder of the volatile forces lurking beneath the park's tranquil surface, prompting renewed efforts to monitor and assess the ongoing volcanic activity. But what would it really be like if Yellowstone actually erupted? What happens if the Yellowstone erupts? A supervolcano's eruption, such as the one potentially lurking beneath Yellowstone National Park, presents a scenario far beyond the scope of typical volcanic events witnessed in modern times. Unlike the relatively contained eruptions we're accustomed to, a supervolcano's explosion operates on an unparalleled scale, with consequences that can reverberate across vast distances. There will first be an initial explosion that unleashes a shockwave of unimaginable power, akin to the detonation of multiple atomic bombs simultaneously. Fueled by an immense release of energy in mere seconds, this shockwave radiates outward from the eruption site, leaving destruction in its wake. The sheer force of the shockwave is nothing short of catastrophic. It brings an intense surge in pressure, capable of instantly shattering walls, roofs, and windows. Even well-constructed buildings may struggle to withstand the sudden and extreme changes in pressure. As the shockwave traverses the landscape, trees, typically flexible in their resilience, are not spared. Despite their sturdy trunks and branches, they can be uprooted or snapped like twigs under the relentless force of the eruption's shockwave, a devastating sight, especially within the confines of a national park. Yet, the terror doesn't end there. A supervolcanic eruption unleashes a torrent of molten rock, gas, and ash from deep within the Earth's core. The sheer magnitude of such an eruption, like the cataclysm that could unfold at Yellowstone, is so colossal that much of the ejected material may not even escape far from the crater, succumbing to the relentless pull of gravity and the overwhelming force of the eruption column. Despite the cataclysmic power at play, the haunting possibility remains of lava flows, ominous rivers of molten rock snaking their way across the landscape. These flows, born from magma so scorching hot that it defies solidification, possess a menacing, albeit sluggish, quality. Unlike the swift torrents of lava seen in other eruptions, the molten rock here moves more leisurely, owing to its extreme viscosity. While this might offer a sliver of relief to those in the vicinity, the urgency to flee remains paramount. Evading the creeping advance of lava, poised to engulf everything in its path, becomes a race against time, a daunting prospect for even the most prepared. Several factors influence how far lava flows can reach, such as the landscape, cooling processes, and eruption size. Typically, these flows would extend up to approximately 25 miles from where the eruption began. Despite being immensely hot, often surpassing 1,825 degrees Fahrenheit, the lava poses a significant threat to anything in its way. This danger isn't limited to people. Even the national park structures are at risk. Nearby buildings and infrastructure could suffer severe damage if they're in the path of the lava. The intense heat could ignite combustible materials, leading to extensive damage and potentially costing thousands or even millions of dollars. It's easy to overlook the impact on surrounding vegetation. The extreme heat can set plants ablaze, worsening the hazardous conditions. As the lava moves, it leaves a trail of destruction, incinerating or severely damaging any plant life. Wildlife in the area faces significant challenges too. Many animals may struggle to flee from the slow but unstoppable advance of the lava. This habitat loss and direct harm could have severe consequences for local ecosystems. The survival of both plant and animal life is threatened by the relentless movement of the lava, underscoring the broader impact of volcanic eruptions on the environment. Volcanic winter. While volcanic eruptions are often associated with earthquakes and lava, a Yellowstone eruption of such magnitude would unleash another peril: massive amounts of ash and volcanic debris into the atmosphere. This mix of fine particles, rocks, and minerals would be hurled high into the sky by the eruption's force. Once airborne, the ash would travel far and wide on the winds, sometimes spanning hundreds of miles from the eruption site, impacting areas beyond the volcano's immediate vicinity. When the ash falls, it resembles something between fine snow and a simple dust storm. As these ash clouds disperse, they don't just float idly. They interact with the atmosphere. The fine particles in the ash can scatter sunlight, resulting in reduced visibility and hazy skies. This limited visibility could disrupt transportation, navigation, and daily activities, extending its effects beyond the local area to influence Earth's literal atmospheric conditions. Moreover, the ash and sulfur particles in the atmosphere form a reflective barrier to sunlight. When sunlight encounters these particles, a significant portion is scattered and reflected back into space, cooling the Earth's surface. This global-scale cooling phenomenon, a volcanic winter, impacts daytime and nighttime temperatures, causing a noticeable drop in overall temperatures. The cooling effect can also induce changes in weather patterns, influencing atmospheric circulation, prevailing wind patterns, and ocean currents. These alterations in atmospheric dynamics may trigger shifts in weather systems and precipitation patterns, persisting long after the eruption has ceased. However, the repercussions extend beyond weather fluctuations. The reduction in sunlight reaching Earth's surface directly affects agricultural productivity, impacting plant and animal life. These organisms are highly sensitive to temperature changes, and while short-term fluctuations may not have a significant impact, prolonged alterations can disrupt the delicate balance of ecosystems. Agricultural industries worldwide rely on optimal growing conditions for crops. and without adequate sunlight or temperature, crops may wither and die. Wild vegetation, a crucial food source for many animals, would suffer a similar fate. Larger plant life, such as trees, which depend on sunlight for survival, would also deteriorate. As omnivores, humans depend on both plant and animal sources for sustenance. A shortage of plant-based foods would drastically alter our diets, and the decline in livestock due to changes in feed availability would further exacerbate the situation. Even aquatic ecosystems would be affected as ash alters water acidity levels, leading to dwindling fish populations. A Yellowstone eruption's aftermath could devastate global food supplies, threatening the delicate balance of plant and animal life upon which many societies and cultures depend. In the end, we're looking at a serious food shortage, with billions of lives at risk of starvation. However, these changes aren't just short-term. They can stick around for years, even decades, wreaking havoc on our world. It's happened before, and it could happen again. The eruption of Mount Tambora. The eruption of Mount Tambora in Indonesia in 1815 is a momentous event in the annals of recorded history, marked by its extraordinary power and far-reaching consequences. This cataclysmic event unleashed the largest volcanic explosion ever witnessed by humankind, earning a remarkable 7 on the Volcanic Explosivity Index, categorizing it as supercolossal and second only to the most extreme rating on the scale. Mount Tambora, though still active, is situated within the Indonesian archipelago and is one of the loftiest peaks in the region. The eruption was an awe-inspiring display of nature's force, spewing immense quantities of ash, gases, and particles into the atmosphere. Mount Tambora spewed nearly 36 cubic miles of ash, rock, and gases into the atmosphere, including almost 60 megatons of sulfur. The resulting ash cloud ascended majestically into the stratosphere, carrying copious amounts of sulfur dioxide gas and aerosols, propelled to significant heights within the Earth's atmospheric envelope. These airborne particles acted as a reflective shield, diverting sunlight back into the void of space and initiating a notable cooling effect on the Earth's surface. The repercussions of this atmospheric disturbance were profound, as evidenced by the climatic anomaly of 1816, famously christened the Year Without a Summer. Across vast swathes of the northern hemisphere, temperatures plummeted well below seasonal averages, precipitating unseasonal frosts and snowfalls during months traditionally basked in warmth. These untimely meteorological phenomena culminated in widespread crop failures and acute food shortages, precipitating severe agricultural losses and famine conditions that afflicted countless communities. Tragically, the eruption exacted a staggering toll on human life, claiming approximately 10,000 lives directly from volcanic activity, with an additional 50,000 succumbing to the ravages of post-eruption starvation and disease. The impact of Mount Tambora's eruption reverberated globally, underscoring the profound influence that a single volcanic event can wield over climate and society. Remarkably, a century later, a similar scenario unfolded in the Philippines. The eruption of Mount Pinatubo. In 1991, Mount Pinatubo in the Philippines unleashed one of the most devastating eruptions of the 20th century. Nestled in Luzon, Philippines, Mount Pinatubo is a stratovolcano, part of a volcanic arc formed along a subduction zone where the Philippine and Eurasian plates converge. The eruption was a cataclysmic event of explosive magnitude. Originally towering at about 14,000 feet, the volcano was engulfed by massive pyroclastic flows, depositing layers of volcanic material up to 660 feet thick across the surrounding landscape. The eruption caused the summit to collapse, forming a vast caldera over 1.5 miles wide. Like the Tambora eruption, Mount Pinatubo spewed significant amounts of ash, gases, and particles into the atmosphere. Sulfur dioxide gas and aerosols were propelled high into the stratosphere, remaining suspended for an extended period. These aerosols scattered sunlight, resulting in a cooling effect felt globally. The eruption forced the evacuation of 100,000 people from their homes and led to the closure of the U.S. Clark Air Force Base. The aftermath of the eruption was profound. The immense ash and debris ejected from the volcano marked it as one of the largest eruptions of the 20th century. In the following year, 1992, global temperature anomalies were observed, with widespread cooling effects. While less extreme than the Tambora eruption, localized temperature reductions of up to 1 to 2 degrees Celsius were recorded in some areas. However, the impact on air travel was significant, with operations throughout the region suspended for months, disrupting normalcy until a gradual return to stability. Health effects. However, it's crucial to recognize that volcanic ash presents more than just an inconvenience. It poses significant health risks, especially to individuals with respiratory issues like asthma or chronic obstructive pulmonary disease. Inhaling fine ash particles can trigger respiratory irritation, leading to breathing difficulties and exacerbating existing conditions. Given the recent global pandemic, which heavily impacted respiratory systems, many people worldwide are already grappling with respiratory problems, and a supervolcanic eruption would only exacerbate this situation further. Moreover, as the ash settles, it accumulates on indoor and outdoor surfaces, presenting a range of issues, from a thick layer of dust on streets and buildings to more severe structural concerns. Ash can infiltrate ventilation systems, air conditioning units, and other mechanical components, causing blockages and reducing efficiency. This, in turn, affects indoor air quality and temperature regulation, potentially creating discomfort and health hazards for inhabitants. Considering the ongoing climate change challenges, with extreme winters followed by scorching summers, the prospect of Yellowstone experiencing a supervolcanic eruption amplifies these concerns. The repercussions would be immediate and profound if the winters became even colder. However, what's even more alarming is the potential exacerbation of the greenhouse effect, coupled with prolonged colder periods. This scenario would likely result in even hotter summers, disproportionately affecting regions around the national park and areas already accustomed to hot summers. With the world already struggling to combat climate change, the looming possibility of a supervolcanic eruption begs the question, could this be the final blow? The economic impact of a Yellowstone eruption. For those who survived the drastic drops in global temperatures and the resulting food shortages, another challenge awaits them: the economic fallout. Entire industries that once thrived would vanish overnight. Those already struggling due to food shortages would lose their jobs, plunging them into dire straits. This desperation would bring out the worst in humanity. Remember the Evacuations volcano eruption in 2010. Though not the largest, its ash cloud grounded over 1,000 flights, leaving millions stranded. Imagine the entire planet covered in ash. Governments will struggle to maintain order as people fight to survive. Looting would run rampant, making business survival nearly impossible. Black markets would emerge, offering basic necessities at inflated prices. In short, the aftermath would be devastating, forever altering society. Yet there's no need to panic. The likelihood of such a catastrophic eruption in our lifetime is slim. Still, it's intriguing to ponder. Who would have thought a place as stunning as Yellowstone National Park could be the epicenter of global upheaval? The scariest part? There's nothing we can do to prevent it. Our only option is to prepare for the inevitable and hope it doesn't happen in our lifetime. The caldera today. Is the era of volcanic activity in Yellowstone coming to an end? Has its explosive violence been tempered by time, so that all that remains are crumbling lava flows and aged geysers? Has the molten rock in the magma chamber under Yellowstone run out? Is it no longer able to produce more explosions or lava flows? When we think of Yellowstone, heat comes to mind, especially for those who have witnessed its geysers or hot springs. Early geologists speculated that the heat in the geyser fluids came from the cooling of new lava flows beneath the geyser basins. They suggested that precipitation and snowmelt seeped into the basin sands and gravels, which heated up and eventually rose to the surface in hot springs and geysers. Despite these beliefs, recent investigations by the U.S. Geological Survey have dated some of these lava flows to be fairly young, challenging the notion that they were ancient. Could there still be molten magma beneath Yellowstone today, considering that the youngest lava flows are only 70,000 years old? a mere blip in geologic time? While direct techniques like deep drilling haven't been utilized to investigate this theory, other methods suggest that magma may still exist beneath Yellowstone. Heat naturally moves from the Earth's interior to the surface, and the geyser basins exhibit significantly higher heat flow than regular areas. Geophysical research indirectly monitors the caldera and its magma body. Seismic research reveals that shock waves from volcanic eruptions and human-induced earthquakes are considerably slowed as they pass beneath the caldera, suggesting the presence of molten material. Data from earthquakes also point to the presence of molten or soft rock near Yellowstone's surface, indicated by shallow earthquake foci. Gravity research further validates these findings, as low gravity values correlate with low rock densities, suggesting molten material beneath the surface. While the era of volcanic activity in Yellowstone may not have ended, its nature and intensity remain subjects of ongoing scientific inquiry. Using geophysical research methods, scientists continue to unravel the mysteries of Yellowstone's volcanic past and present, shedding light on its potential for future eruptions. Thanks for watching. We'll see you in the next video.